Now before we start, what I've done is defined a random variable s. Let s be the random variable number of customers buying sandwiches. And you'll notice that I've defined it as a binomial model. And I know it's a binomial model because, well, I don't know it's a binomial model, I should say. I'm assuming it is because I'm assuming that events occur at random, and we've certainly got a finite number of trials, n being 120, and we've certainly got two outcomes for each customer. They'll either buy sandwiches or they won't, but I'm assuming that probabilities are independent and remain constant. And if those conditions are met, then S is distributed as a binomial. 120, and I've just put the other parameter P here. And P, under the null hypothesis, the shopkeeper says that the proportion buying sandwiches before refurbishment was 0.20, 20%. But after refurbishment, he tests the sample of 120 customers and finds that 31 of them buy sandwiches. And if you've got this binomial distribution, let me just draw you a number line up here, then obviously there can be no customers buying sandwiches all the way up to 120. And if it's 20% that buy sandwiches, 20% of 120 comes to 24. So he's expecting 24 generally to buy sandwiches. But if 31 buy sandwiches, then he's thinking, wow, after refurbishment, then possibly the number of people buying sandwiches has increased. And that is our alternative hypothesis then, that H1 is that P is now more than 20%, greater than 0.20. And what we're asked to do is to test this result using a suitable approximation at the 10% level of significance. So I'm going to put here that alpha is 10%. And this is a one-tailed test. In other words, what we're going to do is I'm going to test this by looking at a rejection region. Okay, I'm going to reject this. Let's just put this down. Reject HO, the null hypothesis, if the probability that S is greater than or equal to this observed value, 31, given that the null hypothesis is true, that is that P equals 0.20, 20%, turns out to be less than 10%, 0.10. Okay, we've got this value of 31 then on here. The question is it outside this acceptable region? Okay. Now we're asked to use a suitable approximation, and that approximation is a normal distribution. And I know that because two criteria are met, okay? And those two criteria is that NP and NQ are both greater than 5. I'll show you. NP is going to be 120 for N multiplied by P, which is 0.2. And if you do that, it comes out to 24, the value we would expect. And that clearly is greater than 5. And NQ is going to be 120 times Q, which is 1 minus P, in other words 0.8. And if you do that, that turns out to be 96, which is greater than 5. So we can now think of our random variable S as being approximated to another random variable which follows a normal distribution. And when you have a normal distribution, then we have two parameters, the mean and the variance. We already know the mean, it's 24, NP. But what about the variance? Well, the variance of a binomial distribution is NPQ. So I can work out NPQ quite easily. We know what NP is. NP is 24. Just multiply 24 with Q, 0.8, and you end up with 19.2. So I've got that the variance here will be 19.2 since NPQ equals 19.2. Okay? So I'm now in a position to try and evaluate this probability here. The probability that S is greater than or equal to 31, given that P equals 0.20. I'm now going to use the normal distribution then. So if I just sketch out our graphs up here for X, and we've got the standardized normal distribution below, we have for X a mean of 24. Now, we're trying to find out the probability of being greater than or equal to 31. 31 is, say, over here. But we've got to be very careful because, okay, S is a discrete random variable, but we're approximating it now to a normal distribution, a continuous random variable. So we have to make what is called a continuity correction. We have to look at the probability X being greater than a particular value. And if you're unfamiliar with this, make sure you just go on my website. There's some tutorials on continuity corrections for you. But what we do essentially is we take our value of 31, imagine a bar drawn either side of that 31 of 1 unit width. So this lower value here will be 30.5 and the one to the right will be 31.5. But we want the probability of S being greater than or equal to 31. We want the area to the right of 31, but when we do this correction to changing it to this random variable X, which is normally distributed, because we want greater than or equal to 31, we have to include this 31 in the bar. So that means we go right up to this far edge here. It's called a continuity correction, and it means that what we need to be working out now is the probability X is greater than 30.5. Okay? So if we work that out, we need to get the corresponding Z value in the standardized distribution. Z. So Z equals the observed value, which in this case is 30.5, minus the mean, 24, all divided by the standard deviation. And that's going to be the square root of 19.2. Root 19.2. Now if you work that out, you'll find you get 1.483 and so on. So working out the probability that X is greater than 30.5 is basically the same as working out the probability then that Z is greater than 1.483 and so on. In other words, this area here. Now to get that area, the tables only give us the probability of being less than a given value of Z. So knowing that the whole area is 1, we can do that this is 1 minus the probability that Z is less than 1.483 and so on. Okay? And if you use your tables for this, the probability of Z being less than 1.483 turns out to be 0.9306. And if you do 1 minus 0.9306, you get 0.0694, which you can see is less than 10%, less than 0.10. So what this means, according to this, is that we're going to reject HO. We're going to reject HO in favour of the alternative hypothesis that P is greater than 20%. So in summary, what we've got here is that this is a significant result. We reject HO, P is greater than 0.20, 20%. And so there is evidence that more customers are purchasing sandwiches. Well, I hope that's given you an idea of how you can go about this question. There is an alternative way, which I'll show you. If you're on my website at the moment looking at this video, you should see another link to the solution to this question if you're looking under the paper, where I go into finding out the critical value. So you might be interested in looking at that, comparing both methods. Both methods are suitable though. Okay?